All right, so we're going to go ahead and look at simplifying complex fractions. And I know just by looking at this first question, it's kind of intimidating. If you can remember what we did last class, whenever we were adding and subtracting rational expressions like this, we're going to follow pretty much the exact same steps because in your numerators, it's going to ask you to add or subtract items like we had on this page. So it's going to be very similar for us. So I'm going to go ahead and look at our notes that are on this page. And we're going to go ahead and start by looking at your directions. So the steps tell you to create a single fraction in your numerator and your denominator. I'm going to put using a least common denominator. So LCD, least common denominator. Next, you're going to set up as a division problem. And this is really important, especially with that single fraction we talked about in the first step. You're going to set up a division problem and then multiply by the reciprocal. So what you're going to have for step 2 is, I'm going to write this over to the side, we're going to have a fraction divided by another fraction. When you have a fraction divided by another fraction, what's the saying that I tell you to do? Keep, change, flip. So that's what you're going to do. You're going to keep, change, flip, specifically when you have a fraction. I'm going to split those two steps. That little line in green is showing that this part is for step 1. This part down here is for step 2. And then the last step is to simplify. And it says in parentheses, factor first if possible. So especially with the adding and subtracting notes, even with the multiplying and dividing notes that I did, I usually told you guys to factor at different parts. So if you think back to adding and subtracting, I told you guys you may need to factor first here. For the questions that we're about to do, we're going to pretty much wait until the simplifying step before we start canceling and factoring things. So let's go ahead and start with the first question. So first, I just want you to take a look at it. And we need to find, like we did on our adding and subtracting notes, a least common denominator. So before I do that, let me refresh your memory. With adding and subtracting, when we found a least common denominator, for instance, for question 2, we needed both of the denominators to be the same. So that's why we made this a 4x squared for these two denominators. We wanted them both to be the same. Same thing down here. We had to pick a least common denominator that we could multiply to make both of these binomials the same on the denominator. So we're going to do the same thing here as well. So Tristan, for the first question that you have on this page, what's a good least common denominator to use? Okay, so for the numerators up here, what's the least common denominator? 8, good. And then for the denominator, it might be a different number, and that's okay. What's a least common denominator we can use for these two? 12, good job. And really quick, what's that 2 over right here? It's over 1. So let's rewrite what I have. So I'm going to rewrite this as 3 over 4. I'm going to leave some space. I see that negative sign, so I'm going to make this a plus negative 1. So I wrote that in pink, plus negative 1 over 8. And then for the denominator, I'll have 2 over 1 plus 1 over 12. So you told me, Tristan, that I need both of these to be an 8. How do I get this first fraction to have a denominator of 8? You're good. And then for the denominator, how do I get both of these denominators to be 12? That's all we're doing. Like I said, it's the same thing we did on the first page. We're just having two fractions we're solving at the same time. So I'm going to scoot this over. Every time I write an equal sign after, that means I'm moving on to the next step. Some students like to draw an arrow going over. I really don't care, but just know how I get from one step to the next. On your tests and quizzes, make sure you know how to show me how you're getting from one step to the next. So we're going to go ahead and simplify the stuff that Tristan told us to multiply in these two fractions. So we're going to make this 6 over 8 plus negative 1 over 8, so I don't lose that negative. And then 24 over 12 plus 1 over 12. Question, Tristan, are both of your denominators now the same? So when I say that, in your numerator, are your denominators the same? Okay, good, I can add those. That'll give me 5 over 8. And your denominator, are both of your denominators the same? Yes, you're going to hear a lot of numerator and denominator today, guys. Tristan, what do I do at this point? Okay, so read out step 2. What did it tell you to do when it's set up as a division problem? Multiply by the reciprocal. So after it's set up as a division problem, we are going to keep, change, and flip. There is methods to my madness, guys. Everything I tell you is for a reason. Don't start looking at this saying, oh, cool, I can start cross multiplying. Do not cross multiply here. This multiplication dot means you are not cross multiplying. If it was an equal sign in the middle, yes, you could cross multiply. What I could do here is I can make this 5 times 12 over 8 times 25. What I would technically have to do is multiply your numerator and denominator and then try to see if anything would reduce. But you can actually make your life a lot easier and reduce it here, so that way you're not messing anything up. So looking at the numbers, Nicholas, is there anything I can reduce here? Because after multiplying, I would just divide the same things anyway. So is there anything I could reduce right now? Let's start simple. Is there anything I can reduce with the 5? Look in your denominator. Is there any number that's divisible by 5 down there? 25. Okay, so what's 25 divided by 5? A 5. So we're going to put 1 on top, 5 on the bottom, because 5 divided by 5 is 1, 25 divided by 5 is 5. Anything else I could reduce? What? 12 and 8. What's 12? Well, that's an unfortunate thing. They're not divisible by the same or by each other. So what will I have to divide both of them by? 4. So this will give me 3 and 2. Okay, let me rewrite my new fraction that I have in green. We're going to make this 1 times 3 over 2 times 5. I'm going to say this again, and I know somebody's not paying attention. I am not cross multiplying. I am just reducing. You're doing the exact same thing you would normally do if you actually multiplied 5 times 12 and then divided it by this product. I'm just saving you some time. So from here, we're just going to do the last bit of multiplying because this is a lot easier, which will give you 3 over 10. Nicholas, please tell me I can reduce that further. Nope, this is it. That would be your answer. Give me a nod or shake. Does this make sense? You're just really combining the stuff we did with adding and subtracting and a little bit with multiplying and dividing fractions, and we're just simplifying. That's all. All right, let's look at example 2. So I'm going to zoom out, and we're going to look at example 2 right below it. Take a second and look at it. And first thing I want to know is what is the least common denominator for your numerator? So, Lorraine, in your numerator, how many fractions do you see here? Just one big fraction. So you really don't need to write out your least common denominator because it literally already has one denominator. So I'm just going to write it out anyway just to be consistent. You don't have to do that part, but I will. For the denominator, actually, down here, Lorraine, what's the least common denominator here? Just x. So let me rewrite my fraction. We'll have that same 1 over x plus 2. That's fine. 6 over 1 plus 4 over x. Where am I going to multiply that x? 6 over 1. So I'm going to rewrite my fraction. Numerator is staying the same. This is a nice one. So we'll have 6x over 4, over x, plus 4 over x. A lot of students will tell me, oh, Miss Tapia, we could cancel. If you cancel here, what happens? Where do you end up? You're back at the beginning, which was a waste of time. So don't cancel those x's. Lorraine, are both of your denominators in your denominator the same? Are both of these x's the same? Good. So now we can make this one big fraction. So we'll have 1 over x plus 2, and then 6x plus 4 over x. Do not try to skip steps, guys. It's just going to hurt you later. Lorraine, what can I do at this point? What do you mean?
Like, it would be 1 over x plus 2 and then multiplied by x over 6x plus 4.
Okay, perfect. And that is a 4. Okay. Oh, fun question. Can I cancel these? Why not? What's going on in this denominator? It's a plus. You're adding. You can't cancel those. How about this, Lorraine? Can I cancel these? Why not?
They don't have the same denominator.
It's not that they don't have the same denominator. I could write it like this.
Oh,
It's because it's adding, yeah. It's still not going to work because it's adding here. So let me ask you guys this, and not just Lorraine, all of you. Can I cancel anything else or reduce anything else from here? No, there's nothing else I could do. So technically, this is a sufficient answer. This is totally fine. If you wanted to, though, looking in this denominator, Lorraine, could I factor anything out? What? A 2. You could factor out a 2. So I'm going to zoom out just a little bit, and in this space underneath your problem, like we've been doing, I'm going to rewrite 6x plus 4 as 2 parentheses 3x plus 2, because if I redistribute it, I'll just get 6x plus 4. And you could rewrite it with that 2 instead. So this is another way to rewrite the exact same answer. You'll have the x on top, and then I'll have 2 times x plus 2 times 3x plus 2. And I know some of you guys are looking at me like, Miss Tapia, this isn't written right. No, it is. I would rewrite it. You could rewrite it as x plus 2 times 3x plus 2. But the reason why I don't usually have you guys write it like this is because you will lose this 2 and forget that it goes in front. So this means the exact same thing, both of these that I have in red and purple, but I just am writing it in a nicer way that you're going to see on your tests and quizzes. This is also the exact same answer as you had above. Is there another thing we could do with that denominator? Say it again. We could FOIL it. If you wanted to, which I'm not going to, you can FOIL this denominator or this one, and you can get one polynomial that you could actually write it with x squared or x squared to the for the highest power. It's up to you. I personally won't. These two answers will be perfectly sufficient. So on your tests, quizzes, homeworks, either of these should work. All right, let's go ahead and look over at question number 4 on the next page. Take a second to look at it. Chris, what would be a good least common denominator to use? Whoops, let me pull this back. Chris, what would be a good least common denominator to use for my numerator? X minus 1, perfect. And then in your denominator, before you guys start saying, oh, I know what x squared plus 1 or minus 1 is, hold up, look up. Remember on that first page where I said wait until the end before you factor? This would be a good question to wait, and I'll show you why. There's always a reason why for me. So down here at the bottom, what's a good least common denominator, Chris? Just x squared? Minus 1, all of that. I'll tell you why I didn't factor it. Last question to you, Chris, is can x squared minus 1 be factored? And if so, what can it be factored into? Perfect. I'll be able to use that, just not right away. Okay, so we've already discussed our least common denominators. Let me rewrite my entire fraction, and let's try to get my denominators in both the numerator and denominator to be the same. I know, I'm sick of saying numerator and denominator, don't worry. Okay, so in this first fraction, we're going to multiply it by x minus 1. That's a 1. And then in the denominator, we'll do x squared minus 1. Technically, in your first fraction up here, you're supposed to distribute that 1, but it's not going to change any of the values. So by distributing this 1, it's not going to change anything. Just keep it as x minus 1 over x minus 1 plus 1 over x minus 1. Second fraction, same thing. If you were to actually distribute that 1, it's not going to change anything. So x squared minus 1 over x squared minus 1. Chris, double check my denominators. In your numerator, are the denominators the same? In your denominator, are the denominators the same? Perfect. So let's write it as one big fraction. So I'll have in my numerator x minus 1, and then we'll have x minus 1 plus 1. In the denominator, x squared minus 1 plus 1 over x squared minus 1. Chris, does anything happen here? Because I technically could keep, change, and flip, but I'm not doing that just yet. Can I do anything here? Say it again. I could factor, but before I factor, is there anything else? We'll look at one thing at a time. Very top numerator. Can I do anything here? Read out the things we have in our numerator. Just read them out. X minus 1 plus 1. Can you combine any of those things? What? And when you combine both of those ones, what happens? They cancel. Good. That's one thing gone. And the denominator of your numerator. I know that sounds weird. Can you cancel anything or reduce anything? No? Okay, that's fine. Anything here. Sorry. Anything here. Say it again. Cancel out the ones. And then for the last denominator down here. No. All right, good. Let me rewrite what you have, and then I'll keep, change, and flip. So in your numerator, of the numerator, we'll have x over x minus 1, and then x squared over x squared minus 1. What I would do is keep, change, flip, and then simplify. I want you guys to finish this part. Do the keep, change, and flip, and then simplify. All right, so double check. I pretty much took my two fractions and I rewrote them down here. So this little arrow is showing what I did next. So I kept this numerator the same. I changed the division into multiplication, and then I took this fraction and I flipped it. So I did the reciprocal. Elias, how did I get from here to here? I factored it. Okay, so I did the difference of squares. So Elias, is there anything I could do from here? Say it again. Okay, so what can I eliminate? What can I cancel? Say it one more time. X minus 1, those are gone. Anything else? I know for sure, I think we both agree, the x plus 1 can't be touched, right? That can't be touched. But this x, how is it attached to this parentheses? What operation? You could distribute it, which means to multiply. And then this x squared is by itself. Could you reduce both of these somehow? Yeah, you could do that. You can do this. So especially when there's two x's in the denominator and one x in the numerator, that's just going to be, this x is gone completely, and this 2 is gone. So you're only going to be left with, in your numerator, you'll have an x plus 1, and in your denominator, you'll just have an x. Elias, let me ask you one more question. Do these x's cancel? Why not? Because the addition sign's in this numerator, you cannot just cancel it. This would be your answer. So you said that you wanted to distribute this x squared, or that x, and make it x squared plus x over x squared, right? Why can you not cancel this, guys? It's still the plus. There you go. You answered your own question. Good question. All right, guys, we're almost done. Let's look at question number 5. I'm going to start you off a little, just with a couple of things, and then you guys are going to try to finish the rest of it. So right now, let's go ahead and flip to question 5. Desiree, is that better? Okay. All right, for question 5, take a second and look at it. Caitlin, in your numerator, I'll put this over 1. What would be a good least common denominator to use? Perfect. This is over 1 in the denominator. What would be a good least common denominator? K minus 2. Guys, this doesn't always happen. Your denominators, for both of the denominators in your numerator and denominator, the ones that I'm highlighting in red, these won't always be the exact same. It just so happens for this question that they are. So I'm going to rewrite this as k over 1 plus 1 over k minus 2. And I'll rewrite the denominator. And then in this first fraction, or for numerator, first fraction, this is what we'll multiply by the k minus 2. And then in the denominator, the second fraction is what we'll multiply by the k minus 2. All right, so Caitlin, in this first fraction, distribute that k. What is the numerator in that first fraction going to look like?
K squared minus 2k.
Perfect, and that's still over that k minus 2 that you told me originally, and I'll add it to what's already there. In the denominator, you'll have k squared over k minus 2 plus, in this second fraction, you really don't need to distribute that 1 because it's not going to change anything. So I'll keep it as k minus 2 over k minus 2. Caitlin, double check. Are both of the denominators that I'm circling the same?
Yes.
It's ironically, all 4 of them are the same, but they are the same in the numerator and the same in your denominator. So I'm going to make one big fraction. So we'll have k squared minus 2k plus 1. And then in your denominator, we'll have k squared plus k minus 2 over k minus 2. I would definitely write this out, guys, as a keep, change, flip. But what are you going to have to do with both of these numerators? Factor. So go ahead and factor it and see what you will get for your answer. I'll let you guys finish this one up. All right, so for sure you should have done the keep, change, and flip. For this numerator, Alex, what did you get when you factored this numerator? What were the two binomials? You're good. K minus 1 over K, and K minus 1. And then for the numerator for the second fraction, before I write this out, I'm going to change this division into division into multiplication, and then flip that fraction. What did this numerator, which is now becoming my denominator, what did that become? Thank you. All right, from here, Alex, I'm going to rewrite this as one big fraction. Some of y'all might think that this step, bless you, is a complete waste of time, but it's really not, because it'll help you see everything in one view so you don't have to guess what's where. Alex, at this point, what can you cancel? K minus 1 and the K minus 2. Really quick, did you cancel both of the K minus 1s or just one? Just one. So your fraction should look like K minus 1 over K plus 2. That should be your answer. Oh, sorry, Alex, one last question. Can I cancel these? Why not? They have adding or subtracting. Technically, the numerator has subtracting, the denominator has adding. You cannot cancel those. All right, let's go ahead and look at question number 6. Take a second and look at it. And I want to know in just a minute what your least common denominator is. Desiree, in your numerator, what's the least common denominator? XY squared, perfect. And the way you can always look at this, guys, is these two need to be the same. What is the other fraction missing that this one has? Or vice versa. What is this fraction missing that the original or the second one has? Okay, so that is a good least common denominator for that. What about for the denominator? Perfect. If you want them both to be the same, how can you make them both the same? Make them x squared, y squared. So let me rewrite my fractions. Oh, and since I have that negative, make it a plus negative. And I have another negative down here, so plus negative, so I don't lose it. Especially on this question, I'd probably put that plus negative to make sure you don't mess that up. So in this first fraction up here, Desiree, what do I need to multiply this first fraction by? This fraction here? This fraction here. And the last one? And don't think, guys, because of how she set this up, that these will cancel and that these will cancel. The whole point of doing this is so you can actually combine them. If you cancel all of this, you're literally just back where you started, and there's no point. All right, so I'm going to go ahead and rewrite this. We're going to have y over xy squared plus negative x, because we need to multiply this negative 1 times x. You have to multiply it, and that will give you xy squared. Remember, main reason why I'm multiplying this is because it's not a positive 1 anymore. It's a negative 1. That needs to change your sign. And then for your denominator, we're going to have y over x squared y squared plus negative x over x squared y squared. Desiree, double check. Are both of the denominators here and here the same? Yeah, I mean, they're not the exact same here and here, but this is the same in the numerator. That works. This is the same in the denominator. That works. So I'm going to make it into one big fraction. So we're going to have xy squared, and your numerator will have a y minus x. And your denominator, you're going to have an x squared y squared, and your numerator within that will have y minus x. We are going to keep, change, and flip. I know you're looking at this like, oh, I could totally cancel some things. Yeah, but you know I'm going to want you to rewrite this first. So y minus x, x squared, y squared. And double check, Desiree, Are you adding, subtracting? What are you doing in between both of these? Multiplying. So there's a little multiplication dot in the middle. We don't write it, but I want you to understand that it's being multiplied. And then down here, we'll have xy squared and y minus x. Andrea, can I cancel anything here? Those are gone. Can I cancel anything else? Can I cancel or maybe reduce some things? Okay, the y squareds are completely gone. And I double checked this with Desiree. You're multiplying between both of these, right? That's why you can do it. Guys, look up for just a second. If you were adding both of those or even subtracting, you could not cancel out the y squareds. But since they're both being multiplied, you can cancel them. Can I do anything else? So right now, let me rewrite what we have so far, because you're absolutely right, but I want everybody else to see it who hasn't. You have x squared over x right now. What Andrea is saying is that you can actually simplify this further. You can remove the squared and the x at the bottom and just leave this as an answer of just what? Just x. It is okay to do this because there is no adding or subtracting happening there. Perfect. All right, you've done a lot of hard work. Flip it over to question 7. Have fun. Y'all are doing that one completely on your own. If you need a little help with trying to figure out what your least common denominator will be down here in your denominator, I would look back at your adding and subtracting notes that we did here, because at the very bottom question, this is how we found our least common denominator. So hopefully that helps. Couple more minutes, guys. I want you to finish number 7 completely. All right, so I'm going to write out what your answer should look like, and then I'm going to show you how you should have gotten this answer. So for your final answer, you should have gotten x over 3x plus 5. And let me show you how to get that for question number 7. So for question 7, that numerator doesn't need to be changed at all. It's just one big fraction, so we're just going to keep it as such. And the denominator, okay, well, that's why I showed you guys the notes that we did last time. When both of these denominators don't match, there's not really a way to just multiply it by one number or one variable to get them both to match. So if you think back to what we did for adding and subtracting, which I had on the board here, I told you that when you're finding your least common denominator, you're just going to multiply pretty much the fraction by what's missing. So for what we have here, let me pull it back. I'm going to go ahead and take the x plus 1, and we're going to multiply that by this first fraction. And then we're going to take the x plus 3 and multiply it by the other fraction. We need to do that in order to get our least common denominator. So it'll be x plus 3 and x plus 1. We talked about that the very first day when we were doing that with adding and subtracting fractions, just so that way you can multiply it by pretty much the denominators that you already have. So I'm going to go ahead and rewrite this. We'll have 2x over x squared plus 4x plus 3. That's fine as it is. Your other fractions, I'm going to rewrite. And then I'm going to multiply. So this first fraction, I'm going to multiply by x plus 1. And then the second fraction, we'll multiply by x plus 3. So from here, I'm going to go ahead and rewrite it. Let me move it over. That numerator is going to stay 2x over x squared plus 4x plus 3. In that denominator, the first fraction, I'm going to have to distribute the 4. So that 4 needs to be distributed. The denominator, though, guys, don't FOIL it out. Leave them just as 2 binomials because we might have to factor it later anyway. In the second fraction, we're going to have that 2, which I need to distribute. So we'll have 2x plus 6 over that same denominator. The numerator I'm not too worried about. This guy up here, it's literally just one fraction. I'm fine with it. But the 2 down here, you want to make sure that both of the denominators are the exact same. These 2 match, so I can rewrite it as one big fraction. So I'm going to keep the 2x over x squared plus 4x plus 3. And the denominator will have x plus 1, x plus 3, and I'm going to put all of the stuff for my numerators. 4x plus 4 plus that 2x, so we're going to add that 2x, plus 6. In that numerator, I'm going to bring it down. I'm not going to keep change flip just yet. I'm going to go ahead and simplify this numerator in your denominator's fraction so it looks nicer. So let me rewrite this as 2x over x squared plus 4x plus 3. And in my numerator now, I'll be able to combine the 4 and the 2 to give me a 6. And then 4 plus 10, or 6 to give me 10. So we'll have 6x plus 10 over those 2 binomials. Once you have that single fraction and it's as simplified as possible, now I would keep change and flip. So I'm going to keep the numerator the same. This denominator's fraction, so this x squared plus 4x plus 3, I would definitely factor that by now. When you factor that denominator, you should get x plus 1 and x plus 3. We're going to flip that other fraction, x plus 1, x plus 3, and 6x plus 10. If you're confused about how I got from here down to this denominator, all I did was use the little x chart, which I'm going to write to the side. So to factor, let me move it all the way over. To factor x squared plus 4x plus 3, and make my little x chart, I need 2 numbers that multiply to 3 but add up to 4. The only 2 numbers you can use are 1 and 3. And since your leading coefficient here is a positive 1, you can just rewrite it as x plus 3 and x plus 1. That's why I rewrote it like that. All right, so before you just start canceling, I'm going to do this one last time. I'm going to rewrite everything as one fraction, so that way you can see everything that could cancel. So for sure, these x plus 1s are gone, and so are the x plus 3s. So what we're technically left with is, let me actually erase that, 2x over 6x plus 10. But I didn't get that as my answer. In this denominator, can I cancel, or can I factor anything out? What can I factor out? A 2. So we'll have 2 times 3x plus, what's the second number? What's 10 divided by 2? 5. Once that happens, let me ask you this, Chris. How is the 2x connected? What operations between it? Say it again. Multiply. So let me ask you this. Can we cancel out these 2's? Yes, you can do that because this 2 in the denominator is being multiplied by the parentheses. This 2 in your numerator is being multiplied by x. So the last thing you want to cancel are these 2's. Make sure you factor that out first. When students try to cancel here and they say, oh, well, I'm just going to cancel this and this, they forget about the 10, and that's how they end up with the wrong answer. I saw way too many earlier of x over 3x plus 10. That's not the right answer, guys. So my final answer is what I wrote up at the top in pink, x over 3x plus 5. That should be your solution.